My name is Michelle Perry, and I work with CS for All teachers housed at the American Institutes for Research. We are pleased to support these webinars and present tonight, Getting Started with Python in the Classroom. Please, if you haven't already, go ahead and introduce yourselves in the chat. At various points, we do like to make these interactive and open it up for questions. Feel free to put questions or comments in the chat at any point during the webinar. And if you're able to at any point and want to speak up verbally, you're welcome to do so. We do ask that while the presentation is going on, you keep yourselves muted to avoid any background noise. And if there is any interference during the webinar, we will mute people as needed. Without further ado, I am going to pass this off to our community ambassador, Jenn Vermillion, and she will be presenting tonight's topic.
All right, thanks, Michelle, and thank you to everyone for joining us. I really appreciate you joining our webinar this evening. I am Jenn Vermillion. I live in Richmond, Virginia, and this is my 19th year in education. I actually started as a 5th grade. Sorry, my dog has an injury, so I have to keep him occupied. I started as a 5th grade classroom teacher, teaching all subjects, and then I shifted into working in educational technology. And then 5 years ago, I began in my current role as Director of Innovative Teaching and Learning at St. Catherine's in Richmond. And I taught middle school computer science classes, and for 5 years I've taught an honors level upper school class. So I'm excited to work with you all tonight and talk a little bit about using Python with students. So a quick overview of where we're headed tonight. We are going to get a little bit of a sense of who's here, and I can already tell from the chat window that we've got some great experience in the room. So I'm excited to hear a little bit more about all of you who are with us. We'll be talking a little bit about why Python, why I chose Python as a programming language for my students. We'll also look at a few basic building blocks just to get started with Python. We'll also talk about where we can program, so places that you and your students can go to actually write their Python programs. And I'll share a couple of ideas from my classes, so things that have worked well with students for teaching and learning Python. And then we'll share a few resources if you're interested in continuing on with learning Python. We'll share some of my favorite resources with you. And as I can tell from the chat window, there's some great expertise here, so hopefully you all have an opportunity to share some of your ideas and resources as well. So in order to hopefully customize as much as we can this webinar, I would love for you all to take a moment to respond to this poll so we can kind of see how much experience we all have with Python specifically. So the question asks, what is your experience with Python? The choices are Python scare me, what's Python, I've never tried programming with Python, I've dabbled with it, or I am an expert. So if you all will each take a moment to submit your responses. All right, so it looks like most of us have dabbled with it, so that's good. So most of us have at least a little bit of experience with Python. We have at least one expert in the room, so hopefully I might call on our expert at some point. All right, it looks like almost all of us. We'll just take a couple more seconds for anyone that has not had an opportunity to respond. All right, thank you so much. So Michelle, I think we're ready to pull the slides back up. All right, so everybody at least knows what Python is, which is a good thing. In my upper school class, so the course that I teach is an elective course, and we have students from grades 9 through 12 who take the course. when I first started teaching the course, I would actually just jump right into the programming language, Python. And I realized pretty quickly that I was failing to demonstrate for the students the wide variety there are of programming languages and the differences and similarities across different languages. So these are two resources I used pretty early in my course. Some of you might be familiar with these. I've included the links to the quiz, which is on the left side, and then this graphic, which is on the right side. Those are included in the link pod. So the first is the quiz. It says, why do you want to learn to code? And this is super quick. There's only a few questions, but it's great for students to work their way through the quiz, and then it will give them a result and tell them which language they should learn. Sometimes they get Python. A lot of times they get a different programming language. And similarly, this graphic on the right is a flow chart that they can follow and answer each of the questions to figure out which programming language would be the best language for the students to learn. This is a great way for me as the teacher to get to know the students. So as an example, we had a student this year who took the quiz, and her answer for which programming language she should learn was R. And so that led to a really good conversation with her about why that was her result, and it turns out that she's really interested in forensics. And so that was great for me to know as a teacher so that I can try to incorporate some of her interests into the class as much as possible. The students can then take the language, take their result, and actually research a little bit more about the programming language that would be the best fit for them, and they can share those results of their research with the rest of the class. Another thing we do, I'll just mention here, is we actually pull up the Wikipedia page if you search in Wikipedia for programming languages, and the students are just astounded to see how many different programming languages there are. A lot of them don't even realize that there are different programming languages, and they're always astounded to see how many different ones there are. So as I said, I don't have a computer science background. I have a technology background. And 5 years ago, when I started to develop the curriculum for this computer science course I teach, I knew that I needed to learn a real programming language pretty quickly. I'd done some block-based coding, but I needed to learn a true programming language. And I did some research, and I talked to some experts, and Python was the language that really came to the forefront. I love using Python with students. It's a great first language. It was a great language for me to learn for my first language. For students, it's pretty easy for them to pick up the basics. It's pretty easy for them to write to create some simple games using Python, but it's incredibly powerful. And so the graphic that you see over on the right shows some of the different applications that were built on Python. I think I read somewhere that about a third of the internet runs on applications built using Python. So for students, there's a lot of relevance there, and they realize they're learning something that's actually used to power many of the applications that they use every day. So if you look at this graphic, you see Instagram, Snapchat, Google, Pinterest, YouTube. So it's interesting for students to look at these different applications and realize that this language that they're learning is something that is powering those applications that they use every day. We also talk about, when we start talking about the programming language Python and they do a little research on it, we talk about the different versions of Python. And so the students are often surprised to realize that the current version of Python that they're learning to program with right now is Python 3. When I first started teaching Python, it was actually Python 2. And so we talk about the importance of different iterations of programming languages and how they evolve and grow over time. We also talk about the fact that there are actual people who developed these programming languages. And so Guido van Rossum is the author of the Python programming language, and so you can find some videos of him online, and sometimes we'll watch some of his interviews so they get to see the person who actually created the programming language. We also talk about where he came up with the name. Does anybody know, I'm curious, anyone that's here tonight know where the name for Python came from? I'll give a minute to see. I can see a few. Yes, excellent, Claudette. So Guido was is a big Monty Python fan, and so that's where the name for Python came from. And you probably won't be surprised to know that a lot of our students don't know Monty Python, so it's a great opportunity to introduce them to Monty Python. Good, a couple of you had that, Rebecca and Tammy as well. All right, so we're going to look at a couple of building blocks. This might be familiar for some of you, but for those of you who have no experience with Python, hopefully this will give you a bit of a foundation to start with. On this slide here, I have on the top the actual code, and then the output when that code is evaluated underneath. So very simple thing that students can start with is just creating print statements. So these are just ways of outputting text or numbers onto the screen. So in Python, most of the keywords, including print, start with a lowercase letter. So this print is a lowercase p. And then you'll see here, after the word print, there are parentheses. So whatever it is that you want to be displayed would go inside of the parentheses. And then text and characters in Python are referred to or known as strings. So anytime you want text to be sort of held together, you're going to put it inside quotation marks. In Python, you can do single quotation marks or double. They just have to match on both sides. So here is one of the most, I guess, customary first programs, just printing, outputting the word hello world. So on the next slide, you see you can go get a little bit more sophisticated. You can have more than one print statement. And again, just following the pattern, anything you want to be displayed in your output, you'll simply put in parentheses and wrap it inside of quotation marks. So here we have multiple print statements, and you'll see the only thing that gets displayed in the output is exactly what is inside of those quotation marks. So similar maybe to some other languages, we have some AP, CSA teachers in the room, so you might be finding some similarities here and some differences with Java. The types of data in Python, primarily the ones at least that we cover in an introductory level class, are the strings, which are really just characters inside of quotation marks. In the example over on the right, I purposely put a number in there just to show you that you can have any kinds of characters inside of those quotation marks. It doesn't just have to be words and letters. You could also have a number inside there. We also have integers, which are whole numbers. So there's an example of a whole number. In this example, if we were to put quotation marks to the left of the 1 and to the right of the 0, that would then become a string, which in Python is a completely different type of data. So once it's a string, Python can't actually do any computational problems with it. So once it's a string, it just gets treated as text inside of quotation marks, and Python doesn't really do anything with it other than hold it there. Floats are numbers with decimals. So here's an example of a float. And then those Boolean values, which are expressions that would evaluate to either true or false. So in this example, 5 is less than 4. That is false. That is not true. So that would evaluate to false in Python. So as you're thinking about the foundation of your program is creating variables, in Python, when you're thinking about creating good variable names, this is actually one of the first I guess real lessons that I do with my students is understanding how to create valid variable names and how to recognize variable names that would be invalid. So in Python, variables must start with a letter or the underscore character. They can't start with a number. A variable in Python can only contain alphanumeric characters and underscores. So no special characters in a variable name. And variable names are case sensitive. So in these examples here, we have age with a lowercase a, age with an uppercase a, and then age in all caps. Those would be 3 different variables. And that's one of the most, I guess, common errors that students make initially is they use a variable multiple times and they don't keep the cases the same throughout. And so Python doesn't recognize variables if they don't match exactly. One of the first activities I have to do with students is, bless you, I think that might have been a sneeze. One of the first lessons that I'll do is I'll actually have students create some examples of valid variable names, examples of invalid variable names, and then we'll throw them all in a pot and pull them out, and then they have to distinguish which variable names are valid and invalid. So it's really important before they start building their programs that they start to understand how to create good variable names. So now that you know what a good variable name is in Python, how to actually declare a variable or create a variable is with an assignment statement. So a variable can hold lots of different kinds of data. A variable can hold a string. So you could set a variable equal to a string. You could set it equal to an integer. You could set it equal to a float. And there's more things you could set it equal to, but for now, these are the basic ones that we start with students. So here's a quick example just showing you what this would look like in Python. So in this code here at the top, we have two different variables that we've created, the x variable in the first line, and we're just using an equal sign to set it equal to our integer value of 5. In the second line of code, we're taking the variable y, and we're setting it equal to the integer 4. So we've created two variables in this code. And then in the third line, we're using that print keyword. And inside those parentheses, this time instead of having a word, we're actually printing our variables, x and y. And so you can see at the output here down at the bottom, it's now displaying for us the value of x and then the value of y. So another quick note here is when you're printing multiple things inside of a print statement, you just separate them in Python using a comma. So because we have more than one variable here, we're just splitting those two variables, we're just putting a comma in between them. If we just had print x, y, Python would not be able to evaluate that. All right, so input is something that's wonderful to use early on. We actually use it one of the first days of class. Input is a great way in Python of making your program interactive so that somebody can actually interact with the program that your students create. So in the sample code in this first line, we've just created a variable called user_name. And we're setting it equal to, and you notice we use the word input here. And then in parentheses, you can put a prompt. So this prompt is usually a clue or a signal to the person who's using your program that they should be responding or typing something into the output window. You could have input and not have anything in the parentheses, and the user would be able to type something in, but they wouldn't know that because there's no prompt. So what happens here is when you use input, whatever the person using your program types in the display window, it will get stored as the variable username. So in this example, when we run this piece of code, the output would say, what is your name? And then I'll show you on the next slide here. So this first line is what we just had. We just looked at this. What is your name? And then if the person were to type in Jennifer, Jennifer is now stored as our variable username. So if we print the string hello, and then we have our comma, and then our variable username, the program is going to say hello, Jennifer. So this is a great first program for students to learn how to take input from the user and how to store it and then use it. So we're just printing that variable username. Comments are another great thing to use, especially with students. So in Python, you can use comments to annotate your programs, and you do that just by using this hashtag. And so when you put a hashtag in front of a line of code in Python, Python just skips over it. So you might have a print statement after the hashtag, but Python won't actually print it. It just jumps right over it. And comments are really useful for students to annotate and explain their thinking. So particularly as they're building more sophisticated programs, I'll ask them to annotate and explain what each section of code is doing using a comment. It's also really nice. Sometimes we'll play a game where one student will start writing code and then they have to pass it to somebody else to continue. And so the next student is actually picking up the code that's partly written. And so it's a great way of seeing somebody else's thinking, and it's a great way of collaborating on code. It's also really nice if students have are having issues with like a longer piece of code, they can comment out a line. So I'll have them oftentimes just add the hashtag to various lines so that they're only really running 1 or 2 lines at a time of their program. And then they can just take the hashtag out when they do want those other lines of code to run. All right, so math is another great thing just to get the students early on experiencing some of the power of Python. So in Python, you can use some of the basic math operators. So the first one is just a plus sign, which is how you can have your program actually perform some computations. In this example here on the left, we have some code where, and I'm going to pause for a minute because I see Brenda has a question. Do variable names typically begin with capital and contain underscore? That is a great question. Personally, I think it's just a matter of style. So I don't know that that's typically like convention. That's how I tend to write my code. So it really just tends to be a matter of style, I think. One thing I do, that's a great question, one thing I do talk about with students is, especially as they're writing longer programs, is the importance of having really descriptive variable names. So sometimes students will try to throw just an X or a Y, like I've done here in my example, and then they get confused as they're working through their program, like what was it that I wanted X to represent again? And so we do talk a lot about trying to use more descriptive variable names. And so for me, I think that's where I end up getting those like underscores, is because I'm having a little bit more of a detailed variable name. That's a great question. So over here, I have some code where I've just created a simple comment showing that this program is going to add. And then I've created these 2 variables here, X and Y. I've set X equal to 5, and I've set Y equal to 2. And then I've created a 3rd variable down here using my convention, which is the capital letter underscore, and set it equal to basically this math problem, right, of X plus Y. So I'm just using this math operator, this addition operator. And then I can print the variable my sum, or I can actually print the X plus Y. Either way, it's going to output the sum of those 2 variables. And I see Claudette has entered a comment here. You can also use camel case my sum. Yeah, that's a great comment. Thanks for sharing that. That's another nice way of avoiding those underscores altogether. Thanks, Claudette. So here we have some very similar problems to the one we just looked at, which is subtract. So just using the subtraction sign. Again, I have my 2 variables, a 3rd variable, which is my difference, X minus Y. And you can either print that, or you can actually print X minus Y. And here again, your output would be the same. It would be 5 minus 2. So 3rd example, following the same really model as the other ones. In Python, the multiplication operator is your asterisk, so shift 8. And so students often get confused with this one. The addition and subtraction are pretty easy to remember, but this is the multiplication operator. So here's an example here of that. And then division is interesting. So there's actually 2 different division operators that I'll have students learn early on. The first one you'll see is float division. So in this example, we know that 5 divided by 2 is 2.5. So when you use the single forward slash, that's going to output a float value, which is the accurate float value. There is a way, if students are ever writing a program, say they were trying to figure out the inventory of the school concession stand, and they really only just wanted to know how many whole packages do they have, or how many whole boxes do they have, or whole candy bars do they have. There's a way that they can just do integer division, which is 2 forward slashes. And you'll see when you use the two slashes, you actually just get a whole number. And you'll notice that it does not round up. It just slices off any decimal value after the whole number. So we'll take a look very quickly at, so we looked at the math operators, and here we have some conditional operators. So some comparison operators, some ways you can start to run, comparison tests. I'm going to pause because I see, I think it's Aletta has a great question. Can you talk a little bit about modulus and how it is used? Yes, so the % is the modulus operator in Python. And essentially that outputs the remainder of a division problem. So in a little bit, we're actually going to jump, I'll do a screen share and I'll take you into one of our programming environments, and I can actually run a modulus problem. But if you were to, say, print 5 and then modulus operator 2, that would actually output the remainder of that division problem, 5 divided by 2. So 5 divided, 2 goes into 5 twice, and 1 is the remainder. So the output of print 5 modulus operator 2 would be 1. So Aletta, does that answer your question? So I'm trying to think of an example. We did a problem, a programming lab one time where the students had to try to print only the numbers in a list that were divisible by 2. And at that point, they had just learned modulus. And so they could use the modulus operator to determine if the remainder, if there was no remainder. So that was one example. Or they were trying to figure out how many people would fit on a bus. And so they needed to know after that division problem, was there any left over? And so if the remainder was 0, they didn't have anybody left over. But if there was a remainder, then they knew they needed an additional vehicle to transport people. So that's one way we've used that problem. Yeah, great. It is tricky, and I always struggle when I'm teaching students trying to find better context for it. Probably the bus one is probably the one that resonates the most. And let's see. Nancy, I might get to your question in a little bit. That's a great question. We might cover that. If not, please help me remember to come back to that. Okay, thank you for asking. So we're going to jump now to these conditional expressions. So these are some ways you can run comparisons in your program. And you can start to build your code so that once a comparison is true, only if a comparison is true, then something will happen. So in this example, we've got the greater than symbol, which is that symbol that you see in line 2 of the code. And then in line 3, we have our greater than or equal to operator, which is the greater than sign plus an equal. So in our code in lines 5 and 6, you'll notice that we're using that keyword if. Again, it starts with a lowercase I. So the way that you'll structure this is you use the word if, and then you put some kind of a comparison. So we have a value on either side of our comparison operator. So we have 5 on one side, and then we have our comparison operator, greater than. And then on the other side, I just put 2 plus 3. You could do a math problem, or you could just have a number. And then after your if statement, you have to have a colon in Python. And then you'll notice that the line underneath is indented. And that's, I think, exactly 4 spaces. And that is telling Python that only if this comparison test is true, run this line of code. If this comparison test is false, skip over the code and jump down to the next line in the program. So in this example here, 5 is equal to 3 plus 2. It's not greater than. So this would actually be a false conditional test. And so it's not going to print DAM. So there would be no output for this problem. If we change this operator to greater than equal to, then 5 is equal to 5. It would be true, and it would print just the word DAM in the output. So similarly, the less than operator is here in line 2, and then your less than or equal to operator. So again, we have our if statement. And if 5 is less than or equal to 2 plus 2, we have our colon at the end, print bam. 5 is not less than or equal to 2 plus 2, so again, we don't have any output here. Another comparison operator that's interesting is if you want to test or evaluate if two things are not equal to each other. And so the way that you do this is with an exclamation point and an equal sign. So in this first line here, x is equal to 4, y is equal to 3. If x is not equal to y, then print they are not equal. So these two numbers are not equal to each other, therefore it's a true conditional test, and that's always a tricky one for students is, okay, they're not equal, so it's true, and then that would print they are not equal. So we use this a lot. We do, one of our early assignments is a number guessing game, and so the user of the program will guess a number, and then the students can generate, we learn how to generate a random number in Python, and then only if those two things are not equal. So if what the player guesses is not equal to what the computer picked, then the program keeps running. So that's an example of a time when you might use the not equal to operator. And thank you, Claudette. I'm looking over here. If you have access to code.org, Principles Curriculum, Unit 4, Lesson 9 has a modular clock widget. Awesome. Thank you so much for sharing that. We appreciate that. All right, so some more, another conditional operator is double equal sign. So asking, are these two things equal to each other? And students forever want to mix up the two equal signs with the one equal sign. So when you're using one equal sign, you're essentially telling, you're saying in the program, these things are equal to each other. When you're using two equal signs, you're asking, are these two things equal? Tell me true or false. So in this example, we have our two variables, and we're running a test, and we're asking, is x equal to y? And if so, print they are equal. So in this case, 4 is equal to 4, and so we do get our print statement to run. If those two numbers were not equal, then nothing would happen. It wouldn't print that print statement. All right, so loops get a little more complicated. We won't go too much into loops tonight unless anyone has specific questions. But I will show you the two types of loops we talk about in my class, which are for loops and while loops. For loops are counted loops. So they're loops that you use when you know exactly how many times you want the loop to run. So this is the syntax for that. It's your work keyword for, and then some loop variable. I just happen to use a looper, but you could use other valid variable names here. And then in range is one way of creating a loop, and then putting your number, however many times you want your loop to run, is the number you would put in parentheses. And then you'll notice again we have our colon, and underneath the line is indented. So the indented line underneath is the body of the loop, and that's essentially what's going to happen every single time that loop runs. So you could have multiple, I just did a very simple example here, which is one print statement. You could have many, many, many lines of code inside the body of a loop. So it's not, you're not limited to just one line. I just kept it simple for the webinar. But in this example, this loop is going to run 3 times. That's the number we gave it in the range. And each time it's just going to print the statement, I'm a loop. And so you'll see the output over here. So when we talk about loops, the first thing you do is just try to have the students figure out how would you make it run 100 times? How would you make it print your name 100 times? And so we start just having them try to play with those values in that very simple for loop, and then we build from there. All right, so the second kind of loop we talk about is a conditional loop. And unlike the for loop, which you can tell the for loop exactly how many times to run, a conditional loop is something that depends on a conditional test. And so when you're writing your program, you don't necessarily know how many times it's going to run, because it's only going to run as long as the condition is true. So in our example here, we have this looper variable equals 5. And then the loop itself starts in line 4. So we have our keyword while, lowercase w, and then our variable looper. And while that looper is greater than 0, and then in this example I actually have 2 lines of code in the body of my loop. So while looper is greater than 0, I want to print looper. I want to print the value of the variable, and then I'm going to take the variable and I'm going to reset it equal to itself minus 1. So something I did not mention earlier is, you probably might have already known this or guessed it, is you can reset the value of a variable in a program. So it's not constant. Once it stays the same until you change it. So in this example, the starting value of looper is 5. 5 is greater than 0. So the first time through the loop, it's just going to print the value 5. Then it's going to drop to line 6. And looper is going to be 5 is equal to 5 minus 1. So our new value of looper is 4. It's going to jump back up to line 4, and it's going to run this conditional test again. So now looper is 4. That's greater than 0. So it's going to print 4. And then it's going to reset itself equal to itself minus 1, which is 3. So it's going to keep doing that until looper no longer has a value greater than 0. And then it's going to exit out of the loop and drop to, if you had a line 7 of code, it would drop down to that. There is a way, and we actually do this, the students love it, most of the time the students love it. I actually tell them to try to create an infinite loop. So we talk about infinite loops, and we talk about how you could get stuck in a loop forever. And I actually have them make one, and it crashes the software program that we use, and they love it. And then we just restart and go from there. But I want them to see what it feels like to get stuck in an infinite loop. So in this example, if we never reset the value of that looper, so if we took out line 6 of our code, and we just said while looper is greater than 0, print looper, it would keep jumping up and evaluating, but the value of looper never changes, so it's always going to be greater than 0, and so that would be an infinite loop, and you would never be able to break out of it. So that's something that we do when we're talking about while loops. I'm not going to go into too much detail here. I'm happy to follow up with any of you afterwards. After we do some introductory Python, we do look at Python Turtle, which is a great way of developing more graphical representations using Python. There's some great resources out there for Python Turtle. The image on the left, I'll usually give them just some instructions on how to code some basic things in Python Turtle. And then I have them, and it's usually right around Halloween that we get to this, they will code a Halloween scene. So this is a student who created a piece of candy corn using Python Turtle. And then on the right, this is not my image. Another teacher does a really fantastic project where the students actually learn how to program the waves they're learning about in physics class. So as I said, you feel free to reach out to me afterwards. I'd be happy to send you some specific Python Turtle resources. But Python Turtle is a really wonderful way to use Python with students in a way that they can visually see, draw and design things. All right, so we'll pause for a moment here. I appreciate you guys have been asking some great questions, but just to see if there are any other questions at this point. Take a look over here. All right, looks like a few of you might be typing, so we'll give this a moment. Do you need to use Pygame? Okay, great. So Aletta, you couldn't have asked a better question. This is actually going to lead us right into the next part of the webinar. And so we're going to look at where you can actually use Python Turtle if you're interested in doing that, in using Python Turtle with students. So the next question is, where can you and your students actually program? So the first year I taught Python, I downloaded idle to my computer, my students' computers. It was really problematic. It was really challenging. It did not go well. We ended up spending several class periods just trying to troubleshoot and get everything working. I discovered in recent years a free integrated development environment called Repl. .it. It allows users to write code in dozens of languages. So this is a great site because after we do Python, we'll do a little bit of Java, we'll do some other languages. You can also program in Python Turtle in Repl. It's completely browser-based, so you don't have to download anything to your computer. And if you work in a public school or a nonprofit, there's an application that you can complete, and you can get, I think it's 100 megabytes within each program and like 10 gigabytes of file storage. So there is a way that you can get free access. You can also set up classrooms in Repl. So I'll actually show you that. I'm going to share my screen at this point. And there we go. And I'll take you on a little tour of where we program. So the website is called repl.it. We included the link. You should hopefully be able to see it on your screen. And when you go, you can sign up here. You'll share your username, email address, and a password. And I'm going to go ahead and log in since I already have an account. And you can actually, if you choose, you can link your account to your Google account. And so once you're in here, this new Repl up here is a place where you can just jump in and start programming in either Python or Python Turtle. So I'm going to click on this, and my favorites pull up because I'm mostly programming in these languages, but if they don't show up for you right away, you can certainly just type in Python or whatever language you're interested in looking at. And you can also change if you're just trying some things out, you may not want them to be public, so you can change it to private and create your Repl. And then here, this little box pops up. You can give it a name, a description if you like, and then you're ready to start programming. So right here is where you're going to write your code. It's great because it gives you some examples you can look at if you're just learning Python. This is the display window here. The students love this. You can go into the gear icon and actually change the theme from dark to light. So they have a little bit of control over what their desktop looks like. So I'm going to actually just write one of our first programs that we looked at. And you'll notice it does try to give you some clues, which you can ignore or not. But once you type your code in this window, you can hit run. And then you'll see your output right over here. Repl is also really nice. I'm actually going to put an error in here. Let's do x equals 5, and then print. I'm going to print a lowercase x. So I intentionally put an error in here. If I try to run this, it's great. It gives you an error message so students can look at this, and we really work on trying to learn to read these errors and figure out from the clues that are given if they can find the error. So in line 2, so we know to look in line 2, and it says x is not defined. So the student may say, well, I defined my variable in line 1. Well, this is uppercase, this is lowercase. And so they can fix the error and run again. The other thing I'll show you in here that's really nice is there's a teacher space. And so you can create a class. So I'll show you my class here. And you can create programming assignments for your students. And so what's great is here are the assignments that we've been working on this semester. We reach a point in my class where some students move really quickly, some students need a little more time. And so they're all in various places. But I can very quickly look in here and see what my students have completed today. So I can look and see how many of my students are looking for feedback on their assignments, how many students have outstanding assignments. So you can also, I'll show you what an assignment actually looks like. When you're the teacher, you can give instructions to your students, and then when you share out, the entire class will see the instructions for that program. So this is how we do almost all of our programming assignments. They can write their code, and then they can test it out in the window at the bottom here. And then when they submit their assignment, I can give them, there's an extra window where I can actually give them some direct feedback and comments, which is wonderful. So this has been a great resource for us. And you can also use Python Turtle. So if you're interested in programming with Python Turtle, which I think was a question, you can do some Python Turtle in here as well. So another place that I recently learned about, I have not personally used this very much, is this Trinket IO. And so this is another place where you could write some Python code as well. So I just wanted to share that. I personally don't have a lot of experience, but I've heard great things. So I wanted to share that with you all. All right, so I'm going to jump back over. There we go. And all right, I'm just checking some comments here just to see if there's any questions. Good, I see there's some resources for online curriculum from Carnegie Mellon, which is great. Good, yes, I agree with those of you saying that have been using IDLE. I personally find Repl, it makes my life much easier to manage a classroom. Students can submit assignments on, also if your students don't have, if you don't have a one-to-one program, it's wonderful because students can log on into their account on any computer and you're able to really quickly access their assignments through that website. I don't know if Trinket works. I'd have to look and see HTML, CSS. All right, we are coming towards the end, so I do want to take a few minutes to share some of the ways that I teach Python with students. So pretty much every day when the students come to class, we'll do some type of a warm-up. It's a great way of getting them settled and focused. It's also a great way of reviewing material or sometimes setting the stage for the lesson that we're going to do that day. So one warm-up that we do quite a lot is a predict the output. This is also a question I ask on tests and quizzes as well. And so I'll just give them a piece of code. There's that Modulus operator. And so without actually using a computer, the students just have to read the code and try to identify what the output would be. And then we'll talk about that. We'll also do warm-ups, and on pretty much every quiz or test, I'll ask questions that ask them to identify an error. So I'll give them some code that has an error in it, and they have to try to identify what the error is. I introduced this after I discovered that too often the students would find the errors and they weren't really learning how to discover and correct their own errors. And so this is a skill that we really purposely practice. Highlighting your code is another one that works really well. I will oftentimes take much more complicated programs, either things that I'm trying to work on and build, or I'll find different pieces of code and programs online. In Repl.it, there's actually a lot of learning classes that you can join, and there's lots of pieces of sample code you can use. And what I'll do is I'll actually take sometimes a code that's like 200 lines long, and it's much more sophisticated than what my students would actually be able to write or read initially. But I'll have them look at it and try to identify, find the patterns. What are the things that they recognize based on what they've learned about Python? So in this example you see here, I found a game, Python Battleship, and we went through and I said, look, everywhere you see a list in this program, I want you to highlight it in pink. Everywhere you see a loop, highlight it in yellow. Everywhere you see a conditional test, highlight it in purple. So trying to get them to understand that they may not understand a full piece of code, but they can certainly look and find the things that they do know and start to break it down and comprehend it that way. They also make, on Amazon, you can order these fabulous erasable highlighters, which are a great tool. So a lot of times we'll use those highlighters specifically for this activity. Some of the labs that we do when we're learning Python, one we just completed was rock, paper, scissors. So I'll have the students actually program a game of rock, paper, scissors where the player can play against the computer. And they have to try to figure out how to let the player type in how many rounds they want to play. So if you remember that input we looked at, the students will have to actually ask the user, how many rounds would you like to play? And then they have to create a loop that will run exactly as many times as the user wants to play. And then they also have to figure out a way to keep track of the score. So For every round, they have to do a conditional test to see that what did the computer pick, what did the user pick, who wins, and then keep track of the score. And I let them work in groups on that one, and we really talk about breaking it down and doing the one piece, really focusing on one piece of that program at a time. Another one that we do is we talk about personality quizzes. So this is a great opportunity to introduce a little bit of safety, a discussion about safety and information, and we talk about those BuzzFeed quizzes that are so popular, and we talk about why those are so appealing, so we talk about the psychology behind them. But then we also talk about the privacy and security issues and what's really happening with that data that the students are entering when they take those quizzes, and what is the motivation for companies to develop and post those quizzes. So we have a really good discussion about that, and then from there they actually get to write their own personality quiz. So they think of a theme, they think of questions, and then they have to figure out how, when the user responds to each question, how are those responses going to lead to the right answer for, which, trying to think of an example, the students did like, which breed of dog are you? So were you a German Shepherd or were you a Golden Retriever? And so they had to think about how to map the answers and keep some kind of a tally. Reading over in the comments, we do rock, paper, scissors game and Scratch for exploring CS. I'm looking for some nice crossover. Yes, that's awesome. I love the idea of taking something that you do in Scratch and looking at the block-based coding, and then what does that look like in something like Python. That's a great idea. Something else we do, I actually got this idea from, we visited an app development company here in Richmond, and I was really surprised by how, and the students were surprised by how collaborative their programming is. And so they do programming sprints where they, as they're working on projects, we actually got to sit in on one where everybody in the room shared what they had been working on that week. They talked about what they had accomplished and what challenges they were experiencing. And so with students, this is wonderful because it normalizes a struggle, and students realize that everybody has challenges with something. And it also gives students an opportunity to support each other. So a concept that might be crystal clear for one student is more confusing for another. They can play to their strengths, and it really creates a much more collaborative spirit and environment. And it also illustrates, or I think helps clear up the misconception that programming is a really isolated occupation. So we'll share I want to share a couple of resources. These are resources that have really helped me. The first, as a teacher of computer science, the first two that you see here, Code Like a Girl actually just came out, I think in September. This book is actually designed specifically for a student audience. It is called Code Like a Girl. The projects could be used with in a co-ed environment. But there's some great ideas. There is a chapter in there on programming with Python, and it does a really nice job of explaining some Python principles. There's also some projects in there. There's some Scratch projects. There's one to build a smart glove, like a smartphone glove. And there's a project like looking at the technology of things like light up sneakers. So it's a great resource to check out. The book on the right, Invent Your Own Computer Games with Python. I love this book. I saw an earlier question about curriculum. I do not have a textbook or a set curriculum. I had to create it from scratch for my class. So this book right here actually has several different games. It has like a tic-tac-toe game. There's a Caesar cipher, a bagel deduction game. And it explains a lot of the concepts in Python, but it gives you the code. And so it's something that you could use as inspiration. It helped me to understand some new concepts. And it's something that you could use if you had a student who needed a stretch or something like that. It might be a good text for a course. So the students could actually type in the code and then start to learn how it's working and how it's running. Yeah, How to Automate the Boring Stuff is great. Same author as this book. This publisher has a lot of really good computer science resources. These next two, this first book is the book that I learned Python. Everything I learned about Python, I learned initially from this book. It's pretty thick, maybe like 300 pages, but I was able to work through it in a week or two, and for me as a complete beginner, it really gave me a foundation. I did try some of the free online courses, and I struggled with them. I found the book to be much more helpful because I could work through each chapter. It explained concepts really well, and there were little programming exercises at the end of every chapter, so I could sort of test my own understanding. And good, I see the John Zell book, Aletta, you use that. This is great, especially for a high school audience. It introduces much more complexity. If you're looking for more complexity with Python, this would be a great course text. Good. Looks like Claudette uses Zell too. Good stuff. And there's one more resource. It's not on the slide, but it should be over in the link tab, the Think Like a Computer Scientist. That is a good free online resource, and so I'll sometimes point students there if they're looking for a little reinforcement or students who want to jump ahead and move a little more quickly. That's a free online resource that I will point them to as well. So I'll stop now. That is the majority of what I wanted to share, but I'm happy to take any questions, and we have a great group here with a lot of experienced computer science teachers. So if there's anything anybody's wondering about, we have a couple minutes that we could answer any questions. Or if you all have great resources that, it looks like you've been sharing some good resources throughout, but this is a great opportunity to share with others. It looks like a few of you are typing in. I'm going to be scrolling up here a little bit to see if there were any comments that I missed. Good, and I see Susan, thank you. It says Trinket does have a course on getting started with HTML, CSS, so that's a great resource. And Maura, I hope this answers your question. I did just write my own curriculum. I pulled from some different sources. So I did look at the computer science, exploring computer science curriculum, computer science principles curriculum. I looked at some of their resources, and so I tried to sort of pull from a lot of different areas, and I used some of these books to kind of help guide my thinking as well. And Nancy, I'm coming back to your question. Is there a limit? I don't believe there is. I'm going to do some research on that. So Nancy, you had asked the question earlier. I don't believe there is, but I'm going to do some research, and if I'm wrong, I'll let you know. Awesome. So Claudette says there is a Python for Educators Facebook group. That is fantastic. Would love to use that as a way to share some resources. So that's a good motivation for me to get back on Facebook. I've taken a bit of a hiatus, but thank you for sharing that, and that's a great resource for all of us as well. Brenda asked, does anybody have a book recommendation for advanced data structures in Python? So we'll see. Trying to think. I know we ordered a book that we used. We had a student doing independent student research on data. I'll see if I can find it and send it to you, but it was specifically on, I think it was by the same publisher that did the Invent Your Own Computer Games. I'll see if I can find that and send it to you. All right, and let's see, anything big data and Python or machine learning. So does anybody in the group have any suggestions for big data and Python or machine learning? Thanks, Aletta. So Aletta's saying John Zell might have another book that covers data structures. Thank you for sharing that. There was one too, let's see if I can find it. It just recently came out. Yeah, Introduction to Machine Learning with Python. And it looks like the author is O'Reilly. or Riley's the publisher, I'm sorry. So Introduction to Machine Learning with Python, that might be a good resource as well. So we are right at 8:30. I did want to take a moment to share some upcoming webinars. So what does a CS classroom look like in elementary school with one of our fantastic ambassadors is on Tuesday, November 12th at 7:30. And stay tuned. So CS for All Teachers will be sharing some CS Ed Week activities December 9th through 13th. So if you are not a member of CS for All Teachers, we encourage you to sign up. There's great information and resources, archived webinars, discussion posts, and resources available on that website for free. I want to say thank you all so much for joining. Thank you for your questions, and thank you for sharing so many great resources with the group.
Thank you, Jen. For anyone who you know who might have missed this, we'll be posting the recording on our website within a few days, and, along with the PowerPoint and resources. As Jen mentioned, please head over to csforallteachers.org, sign up if you don't have an account, and check us out on Twitter. Thanks. Have a good evening.
Thanks, everyone. Have a great night. Good luck with the next month of your school year.